Close the door. Okay. What we learned yesterday? We learned what are the case statements. After that, we started with the index, right? What are the different types of index? Cluster index and non-cluster index. Okay. And what is the difference between this cluster index and non-cluster index? Hmm? Okay, the cluster index will directly route us to that record. Means records are stored in the binary tree leaf node form. Okay, and in the non-cluster index, it will store the address or it will point at the address. Then yesterday we created one table also, right? Which table we created? This table we created, index test table. And in this index test table, how many values we inserted? Yeah, come on. Close properly. Okay. So this is the index table that we yesterday created. In this index table, we are having almost 10,000 of IDs and 10,000 of names here. Okay. So why we created this index test table? So that we can create one clustered index here, and we can understand the difference between the normal query and the clustered query and how it is saving our time. Already for the normal query, I told you how much row it's reading and all. Suppose from index test table only. Now this is without index. We will try. Okay. So without index, suppose if I run here, select star from index test, it is giving me the value. And if I turn on this execution plan here, where is the execution plan? Yeah. And now I will execute it again. Yeah. Correct. Now this is the execution plan. SQL 10 AM. Yeah. Okay. So now if I click on this execution plan, and if I just hover my mouse here, then you can see select star from index test. Okay. The thing is that I think I need to work on some other database because already I did it for the last batch here. So I'm creating this index test here. There is something, the Okay. So now everyone has created this index table, right? So try to fetch the value for where employee ID is equal to 7748. So right select star from index test where ID is equal to 7748 and execute it. After executing, turn on this execution plan from here. Can you see? Turn on this execution plan from here and just hover your mouse here. You should get actual number of rows read 10,000 there. I'm getting one because for previous batch, I think I already created this index test table and everything. So that's why it is giving me this. For you guys, is it showing a number of rows read 10,000? Laptop? For you, it's showing last bench. Just tell me number of rows read, how many rows it is showing? One. For everyone, it is showing one. Okay. Now here, if you see for the tables, then it is showing number of rows reads 8, right? Okay. Actually, it should show when I'm trying to fetch without using the clustered index in number of rows read. It should show okay 10,000. Let me see now. So it is not having option number of rows read, right? It's giving estimated number. Okay. So actually, I think there is some problem in my query that I have written here. That's why I'm getting this type of problem. But when we will, use this without index, it will scan all 10,000 records, and its execution time will be around 0.027 milliseconds. 0.027 milliseconds. Now let's create cluster index on it and understand that how much time it takes. So first, what I did, I created one duplicate table index test underscore cluster index, and I took all the values from this index test table. Okay. Then I just wanted to view the values from this index test table. So I just executed it. And you can see the same values I am getting here in the output. Okay. So 10,000 records. Okay. And Venkat 10,000 till names are present. Now let's create one cluster index. So to create cluster index, we are having syntax called as create clustered index. To create cluster index, we are having syntax called as create clustered index. Grab share from some other class code. Followed by clustered index name. Now, like whenever we were applying some primary key constraint or default constraint, right, or null constraint, that time we were getting some constraint name in the output. Whenever we were seeing the metadata for that particular table, that time we were used to see the constraint name there, right? So same, what am I doing here? I'm creating cluster index and I'm giving name to that cluster index. As I'm creating cluster index, I'm giving ix for the index underscore table name underscore. This is for cluster index underscore. This is the ID column. I'm creating cluster index on which column? ID column. On On which table I'm applying it? I'm applying it index test underscore cluster index table, and on which column? ID. Okay. So this is the cluster index table now. Which one is the cluster index table? This is the cluster index table. This is not the cluster index table. This is the name of cluster index that we are giving. Like when we were giving the primary key constraint, and when we view the metadata, that time we used to get that primary key constraint name in the output, right? The same what we are doing, we are manually giving name to that our cluster index. This is our cluster index name, but it is getting applied on this index test cluster table on ID column. Got it? Yeah. So how I'm following nomenclature? As it is index, I'm starting with ix underscore table name underscore cluster index underscore ID column. Got it? Any doubt in this? No doubt. Now, if I executed this, that means I have created cluster index. Commands completed successfully. So I created the cluster index here. Now let me execute this now. Okay. So how will I do? I will simply select star from cluster index ID. Index test for CI and in bracket ID, where ID is equal to 774. Okay, got the record. Now if I see the execution time, and if I hover my mouse here, then you can see actual number of rows all execution is 1, and actual number of rows read also 1. Estimated number of rows to be read is also 1. And if you see the CPU cost timing is very low. This much is the millisecond. If I hover my mouse here, can you see this estimated time for CPU? It is 0.0001581, and if you see the normal time was 0.011. Which one is lesser? This one is lesser or this one is lesser? This one is lesser, right? Okay. Or else put it in the chat GPT. Chat GPT will tell that this one is, this one is lesser. So this is how we can reduce the execution time. Now we are having very, just 10,000 records, that too having 2 columns. But when we are working with a large data set, where there's a data like rows are almost in the lakhs or crores, and columns are almost thousands or like hundreds of columns there. That time this will play very vital and important role, because it will reduce our execution time. Got it? Yeah. So create this cluster index. If there is any doubt, let me know. First, what you need to do, you just need to create one duplicate table, index test underscore cluster index, and need to give all the values from this indexes table. And then we will apply cluster index on this table, so that our original table will become safe. If suppose any changes happens, then our original table will not have any problem. Done. Okay, I will scroll it down. This is the syntax for creating cluster index. Sure. Next concept we are learning, that is a normalization. Okay. So now how can I drop this? Suppose if I want to drop this cluster index, how can I drop this? Now we already have learned. Suppose any column is having any constraint. Before dropping that column, what we do? We drop that constraint first. So same, before dropping any cluster index table, we need to drop that cluster index name first, and that's why we had given this name first here. So if I want to drop this index test table, then I need to drop this clustered index name that is given to that table. So alter table index test CA. Already on this index test cluster index table only we had applied this cluster index, right? So if I drop this, this constraint will be, or the cluster index will be dropped from that table. Okay. Message line 138. Let me turn on the lines first. Could not get constraint or index. I will tell you about this. Okay, the normalization. Many of you have heard before. Okay, one. Then, how many of you have completed engineering before coming here? Okay, from which branch? EIML. Yes. And you? IT. Then have you learned SQL in college or not? So in SQL, they might have taught you what is normalization. How? They were not getting salary there. I will go ahead. Like my cousin maternal uncle lives in the USA. His son is in 6th or 7th class, I think now. And I just while sharing, I told him that I'm teaching Excel here. And he asked me, okay, which students you are teaching? I told him that everyone is like MCA, BCA, BSc, or MSc, or engineering graduate. All are the graduate or the postgraduate. He said that what is there to teach in Excel? And I told him that I'm teaching VLOOKUP, pivot tables, how to create visualization, and VBA macro. Then he said, "No, my son is in 6th class, and just 1 month back, I submitted a project on Excel. And in that project, he has to draw some insights by using pivot table, by using visualizations available in the Excel, by using lookups and all." So I told, yeah, this is USA, that is USA, this is India. So in like, if you see all the developed nations like UK say or USA say, the curriculum is too harsh. Too harsh means they give focus on the practical things more. And while teaching the practical things, they will tell students first that this is going to be important when you are doing this. In India, thing is that nobody will tell you the importance. What are you doing now? Suppose if I understood that, okay, after learning this, I can do this, and this will be used at that place. So we'll connect these dots and you will learn that properly. But if you are not aware of where you will be using that thing, you will be simply learning to clear that exam. Then your vision becomes very narrow. That why am I learning? So that I can clear my semester exam. That's your vision becomes. But when the teacher will tell you before starting that syllabus, okay, this is the SQL. It is used in front end, back end data. Everywhere SQL is used. So whenever you will start working in industry, 20-25% of daily time you need to spend on this SQL to extract the data. Even if you are working as a developer, then you need to push some photos, videos there to show on the website. So there you will be using SQL. So that time you will feel something that, okay, it is very important. I need to use this in my future career. So you will learn it properly. And even while teaching, teacher should give you some practical examples that how it is being used there, so that it will be with you forever. But in India, nobody does that. Even students are like him, like went to the week off, like on Saturday, Sunday they will sleep. On the other day they will tell teachers it was Sunday, I was taking rest. Teacher says, okay, if he's taking rest, then why should I be worried? I should also take rest, right? So everything, whatever you are learning here right now, everything you wanna use in the industry. Everything. Even I have added some more topics here by my own. The things that I'm working in my company, I'm teaching everything here. I'm not missing or leaving any single point behind. Okay. So normalization is like OOPS concept. What are the OOPS concept? OOPS concepts are just theoretical, logical concept. There is no separate syntax, right? How many OOPS concepts are there? 5. Okay, first one. Class, object, then. Okay. Suppose if you want to create a encapsulation class, do you write a create encapsulation class? No, you don't write. Those are the logical concept. Just you need to remember that logic. That's it. Okay. So those are the theoretical kind of concepts you can see. Just we will be keeping that concept in mind so that our program or our code can be easy for access or easy for alter, or we can make it code very great. So same normalization is also a logical and the theoretical concept. Logical or the theoretical concept. There is no syntax available in the SQL to create 1NF, to create 2NF, to create 3NF. There is no syntax available. Okay. So why normalization is important? Suppose I'm having one employee table. Suppose I'm having this employee table here. This is denormalized table example I'm giving here. And first column is here employee ID. Second column is here name. Third column is employee age. Fourth column is department here. Okay. So if you see in the employee ID, I'm having one value here, 1, 2, 3, 4. In department name, I'm having Dinesh, Santosh, John, and Smith. Employee age 27, 28, 25, and 29. Now in department, if you see, this is software. Okay. The same software is represented here by ESW. And suppose here also he is representing software by saying ESW where. ESW. That means I want to tell or I want to mention in my database in the department that particular person is working in the software department, but we 10 people are working in that table, 10 people are updating that table. I am inserting software. Any of my colleague inserted ESW and another colleague is inserting ESW where. Yes, why? Now all of three mean to write software. Got it? But everyone is using different nomenclature here. So because of that, what will happen when I will try to fetch all the employees from the software department, and if while fetching, if I'm using this software spelling, I will get the records for only those employees whose department spelling is spelled like this software. But these also people are working in the software department. But as we are using some different nomenclature for the same department, we will not get the proper records. So first normalization rule, 1NF tells that, first normalization rule, 1NF tells that there should be a standardization while giving the nomenclature. If I'm inserting software, then everyone should insert this like a software. Nobody should use it like SW or SW. So this is called as data redundancy. If one name is being inserted in a different ways, that is called as data redundancy. Okay. So normalization is the process that helps us in reducing data redundancy in accordance with a series of normal forms. Okay. So there are three normal forms. Actually, more normal forms are getting developed because as it is a theory concept. So everyone is coming with some different logic and everyone is, guiding that, okay, go with that logic so that your table will be easy to access, your table will be easy to modify, your table will be easy to update or delete. Okay. So as of now, there are three normal forms. I think there are many normal forms, but we will learn just three. Even if you learn these three normal forms, that is more than sufficient for you to work efficiently in the organization. Okay. So the first type is first normal form. That is also called as 1NF. Okay. Second type is second normal form. That is called as 2NF. Third form is third normal form. That is called as 3NF. So why we are learning this normalization? First one is that drawbacks of data redundancy, because to remove the data redundancy. Then let's see what are the drawbacks of data redundancy. First drawback is data maintenance becomes tedious because we are giving three different names for the one department. It will be hard for us to maintain our data, right? Next, data inconsistencies pop up. Data manipulation issue. Manipulation means update, deleted. What are the DML commands? Update, delete, then select. Those are the DML commands. Okay. So suppose if I want to manipulate that line, if I want to suppose promote all the software department people to the some other department. If I'm inserting this software, then these people will be there in the same department. For this value will not be changed. Next one is a data accessibility issues. Then next one is a space crunch. Okay. Next, let's learn this first normal form. So what this first normal forms suggest us to do. First normal form tells us that every cell must have single data value. Every cell must have single data value. That means if you see our denormalized table, then this department column is having more than one value. Can you see? More than one value. Now this Dinesh, age 27, is working in software department also, in testing department also, in database department also. But it's not humanly possible for to work in the three different departments. Even suppose any employee is taking working in two departments, then there should be two different columns then. Department 1, department 2. So the first normal form suggests us that every cell must have how many values? Single data values. every cell must have single data value. So what we will do in this department column, we will make sure to have single data value. Suppose this Dinesh is working in a software, there should be software only, not the testing. And if suppose Dinesh is working in software plus testing, then in this department one column, it should be software, and there should be a some other department column, department two, and then it should be a testing. Got it? So this is how the first normal form says. And another thing is that in the first normal form, we need to maintain the what? Like here, we were using 3 different names for the one department. So we need to maintain one name for the one department. Okay. So what we will do here to convert, this is a denormalized table. So to make it normal by using the first normal form suggests us every cell must have single data value. That means first column is having single data value, second column is having single data value, third column is having single data value. Then where are the multiple values present? These are present in the department values. Okay, so we need to normalize this table. To normalize this table, what we will do, we will create a one department table, and we will use lookup ID for the department table. Okay, so like this, you can see I am creating a normalized setup, and first I am creating a department table to give the lookup value. Now, how many departments are there? First department is a software, then testing, then database, then management, then sales. Then there is one more department called as finance. Okay, so I will give here finance. Yeah. What am I doing here? Each department name, I'm assigning some department ID so that my employee will not make any mistake. If any person is working in the software, so he will write 1 there. If any person is working in a testing, he will write 2 here. Any person is working in the database, he will write 3 there. So what I did in the department table or the department column, I saw what are the different departments are there, and I normalized that setup by creating a department table, and I assigned the lookup value. Okay, and in the lookup value, I gave different department IDs to the different department name, and now I normalize that table, employee ID, name, employee age, and in the department. Suppose this Dinesh is working in a software, I will give here 1. Then if Santosh is working in a testing, I will give here 2. If John is working in a finance, I will give here 6. If Smith is working in a testing, I will give here 2. Got it? So what we did here, we normalize this complex table by using one normal form. And one normal form says that every cell must have single data value, and we achieved that single data value. How we achieved? We created one new column there or new table there, and we give the lookup value for that table. And how we will do this? We will create this table, and while creating this table, we will give this primary key constraint to this department ID. And then in the normalization table, while creating this department table, we will use the foreign key, and that foreign key will refer to this department column. Got it? Yeah. So that whenever I'm giving here one will represent for the software. And how we will join or connect these tables? I will connect these tables by using the foreign key reference, and I will give department ID as a primary key, and here department as a foreign key that will refer to this normalized setup table. Any doubt in this? Understood what is 1NF? Okay, I'm giving you 2 minutes. Just read it once. And if there is any doubt, let me know. For the first normal form, read it. Done. Shall I go ahead with the next normal form? This is just a logical concept, okay? And how we are going to implement in the practical way? We will create one normalized setup table. We will use here primary key, and then we will give here foreign key reference. That's it. Okay. Next form is a 2NF. 2NF means second normal form. Now to apply the logic of second normal form, that table should be present in which normal form? First normal form. If the table is not present in the first normal form, then first we will convert that into the first normal form, and then we will think of second normal. If needed, then only we will apply. If not needed, we will not apply. Now, if you see in this table, do you think that we need to add some more normal forms here? No. Table got sorted, right? Employee ID, name, employee age, department. That's it. Do we need to add second normal form? No. But there will be many more complex table where we need to add second normal form. For that, second normal form, to apply the second normal form, that given table must be in the first normal form. Partial dependencies are removed and placed in a different table. So what we are going to do in the second normal form, first we will make sure that each cell is having single value, single data value in the first normal form. Second normal form, we are adding this second condition. Partial dependencies are removed and placed in a different table. We will remove all the partial dependencies and place it in a different table. So let's take, we are having one example for denormalized table. And in this denormalized table, we are having first column as a course name, second column as a start date, and third column as a title. First column, course name, second column, start date, and third column as a title. Now tell me, is it in the one normal form or not? Yes or no? Yeah, it's in the one normal form. Because if you see, course name is only one in the one cell, then date is only one in the date cell, and title is only one in the title cell. There are no like more than one data values present in the cell. So it is in the first normal form. Now what second normal form says that remove the partial dependencies. Now what are the partial dependencies? If you observe this denormalized table, then you can see when any student is opting for SQL course, then the title is given as a SQL development. MSBI course, MSBI development. AWS course, Amazon Web Services training. SQL course, SQL development. SQL course, SQL development. If some other students comes and he joins again MSBI, then what will be the course name here? MSBI development. MSBI development. That means if you see, whenever I'm using SQL, then title is going to be SQL development. Whenever someone is opting for MSBI course, title is going to be MSBI development. Whenever anyone is going to opt for the AWS course, title is going to be Amazon Web Services. That means these two columns are partially dependent on each other. These two columns are partially dependent on each other, and these partial dependency we will remove in the second normal form. So how will remove? We will create a one normalized setup table. We will create one normalized setup. First, we will create a new table that holds name to the title mapping. Now, what I did here, I give the course name and I mapped all these course names to the title. So, first course name was SQL. I mapped with the SQL development. MSBI, I mapped with the MSBI development, and AWS, I mapped with the Amazon Web Services training. Okay. So now, how will I create this normalized setup table? I will create this primary key, right? I will create this course name as a primary key, and this is the title name as a, like, even if you don't give the constraint, that is fine. But this primary key is going to refer this title value. We map those courses with the title, and then what we do, we put it in the normalized table. Now in the normalized table, I will be having course name and the start date. Now this course name is a foreign key constraint that is referring to this primary key constraint. So whenever I am writing here SQL means title is going to be SQL development. MSBI means title is going to be this MSBI development. So what I did, I removed this partial dependence. And even if I remove this title column from this table, as I'm using this foreign key reference to this primary key table, so SQL means SQL development title is there. Got it? This is called as second normal form. So in the first normal form, what we will be doing? we will be making sure that each cell will be having single data value. Second normal form, okay, we will remove partial dependencies of one. Any doubt in this? No doubt. So take 2 more minutes and read this second normal form. Where are you really? You joined in the laptop. You come for the mock, I will take a class. Is it done? Everything? Any doubt in this first normal form and second normal form? Yes or no? No? Okay. Shall we go ahead with the third normal form or shall we see it in the tomorrow's class? What do you say? Okay, let's see. We are having 5 more minutes. We can complete this third normal form and then I will share this notebook with you so that you can use it as a notes and you can go through it. So the third normal form, to apply this third normal form, that given table should be in the second normal form, two normal. Second normal form means first condition is that each cell should have one data value. Second, partial dependencies should be removed. Then only we can jump on this third normal form. Okay, and as these are the logical concepts, so these are not the hard and fast rules are not set up there. Many times, even if you don't remember what is first normal form, second normal form, you will make sure to have one data value in each cell. So when you will start working in organization, even if you don't remember what is first normal form, second normal form, third normal form, you will follow this procedure automatically to make your tables more precise, more concise, and more readable. You will make it automatically. So many times, what I'm trying to say is that many times it is not important to divide those table into the different tables and then try to make that table with a less columns. Actually, what are you doing here? Initially there were 3 column names, right? So by mapping this course name and title, we got only 2 column names. Okay, so always it is not beneficial or always it is not important to do that. If there are suppose 20-25 columns and if suppose 5 or 6 tables are having partial dependencies, then that time it is important because we are reducing the number of columns there, so we are making it more readable. First normal form is important. You need to make sure that each cell is having single data value. Partial dependencies, removing or non-removing, that is up to you. That is up to your table size. If already your table is having only 3 columns, then there is no need to remove it. But if suppose more than 5 or 6 columns are having partial dependencies on other 6 columns, then it is better to remove. Now the third normal form says that the given table should be in the second normal form. And what we are going to do in this third normal form, non-primary key columns should not depend on other non-primary key columns. Non-primary key column means what we are doing here, we are giving the primary key constraint to this column and we are mapping it to this some other, like primary key constraint mapping it to this so that we can use it here for NK reference. So third normal form says that non-primary key columns should not depend on other non-primary key columns. Why? Because if I try to match non-primary key columns with the other non-primary key columns, then it may happen that suppose this is not the primary key, this is the non-primary key, then here SQL may come again, right? And here, as it is not the primary key, then it can take the duplicate values. And title, suppose I am giving here SQL administrator. SQL administrator. Now, when I will insert the SQL here, our SQL server will get confused whether to give SQL development or SQL administrator. So that's why non-primary key column should not depend on another non-primary key column. Primary key column can depend on the non-primary key column because that primary key column is referring something. Okay. Next example below, title is not dependent on this employee ID. Let's see. This employee ID and this title, is it having any relationship here? No. This course name and title is having a relationship, but this employee ID and title is having any relationship? No. So both are the non-primary column. They should not be dependent on each other. Got it? Yeah. There is no transitive functionality. Example below, department name should be replaced with the department ID, a primary key of a different table. I think we should start with tomorrow because it's already 11 o'clock. Other students will be waiting for me, and you guys are also in rush to go home and have some breakfast and all. So let's see tomorrow. What is this third normal form? I am going to share these notes today itself. Now only I will share. And also for your batch, many assignments are still pending. So I will share the assignments, complete the assignments, and tomorrow after completing this third normal form, we will start with the module number 4. Okay. So thank you so much for joining. Have a good day.